We want to build hardware that is enabling for an expansive list of applications. I mean, essentially, the brain is a data organ. Everything that we see, everything that we experience is data. Everything that we do originates as data in our motor cortex that's sent out to the muscles in our body. Cognition is neural data. Mood is essentially neural states, which you can say are neural data. And so a brain-computer interface can read and write neural data, which means that it can treat just about any neurological condition or most physical conditions that relate to a breakdown of the brain and the body. And so we want to just keep building better and better hardware so that we can do more and more for the brain using these devices.
Still, we have no idea how human brain works in any single details. We have no idea what consciousness is. That's something that we can call mystery of the human brain.
Yeah, it's interesting that you say that. I mean, yes, everything you just said is true. The brain is still mysterious and much of it is unknown. But I think that the beauty of neural engineering is that we don't have to completely understand the human brain in order to provide meaningful brain therapies. If you look at, let's take for instance the vaccine. The first vaccines were being used successfully and saving millions of lives more than 100 years before we even really understood what antibodies were. In the 1700s, people were getting effectively vaccines against smallpox, and yet we didn't understand the molecular biology of how the genetic material that form antibodies are rearranged until the 1970s. We essentially didn't understand the detailed mechanisms of the immune system until the modern era, and yet vaccines were saving people before that. We don't understand perfectly how motor representations occur in motor cortex, and how neural circuits, form motor intentions and motor planning. But what we can do is we can listen to the motor cortex, and we can instruct a person to attempt to make movements, and after they attempt to make a number of repeated movements, we can build a decoder to predict what movement they're trying to make based on their brain activity. We don't really understand at a detailed nuts and bolts level all the computations that are going on that precede movement, but what we do know is that we can predict what someone's trying to do based on their brain activity. And I think that pragmatic solutions like that will allow us to go into a lot of different brain areas and say, maybe we don't know all of the neurobiology of attention or of depression, but if we can understand when someone's paying attention and when they're not, or if we can understand when someone's depressed and when they're not, we can use that signal to help people optimize their life.